Good. So yeah, Julia programming language. I've had a crack at it before, and I didn't get very far with it, and just kind of gave up. And I find for myself, the thing that helps me to get into a new programming language is if I have something that I'm interested in that I'm going to create with it. So today what I'm going to do with the Julia programming language is I'm going to analyze some COVID data from Brazil's Ministry of Health. So I put on my Ashley Bloomfield Curve Crusher shirt. Here it is. The Curve Crusher. That's Ashley Bloomfield. He's the Director General of Health here in New Zealand. He's a bit of a famous figure here. Someone actually got a tattoo of him on their leg for crushing the curve here in New Zealand. Controversial among some people, famous and beloved among others, bit of a divisive figure. Anyway, I got the t-shirt, I'm wearing it, I'm going to look at this COVID data from Brazil. I saw this article on Bloomberg today. Let me see if I've still got it up here somewhere. Bloomberg. Let's switch to the studio anyway. What am I looking for? This one, next scene. Turn me into a floating head. Yeah, I tweeted about it. I'm not very impressed with the... Cool. Friends of mine in Brazil are messaging me. On Twitter, I tweeted about it. Let me pull up the original Bloomberg article. Let's have a look. Here it is. So this is the original article that I saw. Come on. Yeah, Brazil hits record for COVID deaths as hospitals near collapse. And I wasn't very impressed by this. It says about 20 states have more than 80% of ICU beds filled, which isn't enough data to actually establish the case that they're making in here. Doesn't mean that it's not true, just means it's not established by this data. So I drilled down more into data. First I did some research on ICU capacity. Let me close down some of these windows because my machine is now freaking out. Let's close some of this stuff. Come on. Quit out of these things. Quit. Quit. Should close a bunch of these. Google Chrome uses a lot of resources. Let's have a look. So yeah, I read some papers on Brazilian ICU capacity planning and optimization. Something that I'm kind of interested in is optimization. Processes, that type of thing. That was other research on other stuff. So I spend my Sunday afternoon. Not these ones. That's an interesting book, actually, about the process of vaccine clinical trials. Not these ones, not this one. Twitter, I'll close that because that takes up a lot of resources. Get rid of that. Some good websites of data. Like you can download massive CSV files from Brazil with all of the data in it raw. So when I saw that, I was like, hey, let's have a look at Julia to be able to process it. Nope, that was about nurses, aging population in Brazil, Google Translate. My Portuguese is okay, but it's not amazing. I speak Spanish fluently, so I'm good with that, and I can puzzle my way through Portuguese, twitter.com. Let's make sure that my Twitter updated with the correct thing. Let me move this over here so it's not so boring. Tweets. Okay, so let me tweet out that I'm actually streaming. Here we go. Tweet. Using Julia to analyze COVID data from Brazil's Ministry of Health. Using the Julia language. Tweet. Let's try a different soundtrack. Switch. Okay. Let me just check in on myself and see if I can actually hear anything. Play. Unmute. I switched my sound card. Yeah, it sounds okay. It's cool. Using Julia to analyze COVID data from Brazil. Okay, so this is the COVID data. Go back to the beginning of this track, maybe turn it down a little bit. Anyway, I got the data, massive CSV files. One's like 23 megs, but one's like 200 and something. So you can't really open it in a spreadsheet or a, a basic text editor. So hopefully Julia will, I don't know, do some kind of lazy analysis or something. Dun, dun, dun. In my tweet stream, I put the, it's a really cool differential algorithm for calculating ICU optimization based on wait times rather than simple utilization. But even just looking at the data, I got some interesting, here it is here, this one, this paper. Open in a new tab. Let's close this. Here we go. Move this thing over here. Demand forecasts and optimal planning of intensive care unit capacity. I mean, boom, is that just like on the money or what? And this is like from Brazil for Brazilian ICUs, so interesting. But, as Gustavo pointed out on Twitter, the ICU beds are not evenly distributed across the country. And this is one of the things about like using averages and making broad kind of paintbrush statements with statistics is risk is not evenly distributed. ICU beds are not evenly distributed. You are not an average. As a competitive athlete, I know that like if you kind of do the average thing as an individual, you'll probably be okay. But if you're like competitive, then you need to be doing something that's specifically optimized to your situation in order to get like outlier results, which is what you're after if you're competing, because nobody wins by being average. You only win by being an outlier. So anyway, I got the data. So from these websites here, not this one, not this one, this one. No, not this one either. From here. It's called SRAG in Portuguese, Severe Acute Respiratory Syndrome, which is SARS. It's Síndrome Respiratorio Aguda Grave, something like that. It's basically backwards, Severe Acute Respiratory Syndrome. So I downloaded the data dictionary from here to explore, and then to go down is the other option, to go down, to download. I use Google Translate to translate that page. There it is, Síndrome Respiratoria Aguda Grave. Updated on the 20th of the 1st. So this data is like 2 months out of date, or a month and a bit out of date now, a month and a week or so, 2 weeks. First thing that I saw that's interesting in here, I'm going to see if I can get Julia to pull this out, is from the beginning of the data set here, I don't know if these are weeks, but if you see influenza A and B starts to rise at this point, 61, 78, 89, 110, 190, 190, 335, 143. So now it starts to drop, 68, 44, 30, 22, and now it's like in the, up to 30. Whereas at this point it was at 335. Be interesting to see that as a plot. I mean, there's different kind of hypotheses you can make about that. Like maybe in this early stage, influenza A and B were being misdiagnosed as SARS-CoV-2. Now they're not. Or things that were influenza A and B are being categorized as SARS-CoV-2. It's difficult to say. Statistics will never tell you the true story, give you an approximation. But anyway, the main idea here is to see what I can do with Julia with this data set. So let's do it. Okay, I've downloaded the data set. I've downloaded Julia. Now I need to run these commands here to make it kind of locally available. I installed the Julia extension for VS Code into my VS Code. So first thing is get rid of any existing link for Julia, because I had 1.4 installed before. It's funny because I just deleted it like earlier this afternoon. I was like, I'm not using that. I'll get rid of it, which made me think of it. Okay, so I've added it into my path. So if I now run Julia here, it should start the I don't know, interactive interpreter or whatever. Yeah, okay, cool. There we go. Okay, so it's installed and it's running. Now, documentation. Let's see how to use this thing. Scientific computing, slow dynamic languages, compiler, different from interpreters used for like Python and R. Might find the performance is unintuitive. Find something slow, read through the performance tips. Okay, once you understand how it works, it's easy to write code that's nearly as fast as C. Optional typing, multiple dispatch, good performance, etc., etc. Okay, core language imposes very little. Written in Julia. Okay, multiple dispatch. I'm not even sure what that is. Dynamic languages are being typeless. They're not, of course. Okay, manual. Getting started. Okay, we've got a REPL. Control D to get out. So it's kind of like Python. Or exit. Okay, cool. To run code in a file non-interactively. Okay, no problem. Okay. Put the code into a script. Okay, script.jl. Okay. See, scripting for writing. More information on writing scripts. That could be interesting. So I guess the first thing to do would be Explorer. Open a folder. Create a folder for this. So workspace. Julia. Yep. Open that. Okay. So I should probably put the data file in there. The data file is called Transparencia and Inflood. Okay. Terminal. New terminal. Move. This is my downloads file. Oh boy, this Ashley Bloomfield shirt is pretty warm with my light on. Platform IO doing its thing. CPU going nuts. Okay, downloads. Inflood. Downloads. Inflood. Okay, I got the data in here. Okay, cool. Next, Julia. Scripting. Yeah, okay. Getting started. Okay, you can start it in parallel mode. Okay. I guess the first thing I need to do is read in a CSV file or something. The learning page of the main Julia website. Yeah, okay, because this looks like, this is more of a reference than anything else. Yeah, it's a reference. I just need like a, how do you actually do this? Exorcism. YouTube. Okay. MOOCs created using Julia. Oh man, I just need like a, okay. Blog. Let's Google getting started with Julia. I need someone's dev.to, dev.to, or getting started with Julia, or like a Medium article that's just like a concrete example. Start an interactive session. Learn Julia, concise tutorial. Maybe. Books. Really? Okay, let's try this one. So they really need to go deep into the installation. Yep, cool. Hello world. Julia box. Oof. How do I just get a data file and do something with it? Don't make me go back to JavaScript, because I mean, I could just do it with JavaScript. Getting started with data analysis in Julia. Oh, look at this. A walkthrough using data on COVID-19. This is what I'm talking about. Goodbye. Yes. Okay, we've got a few packages. Keep it simple. CSV, data frames, dates, and plots. Yay. Reading data. The URL. Okay, the path, the file. Okay, cool. Yes. Okay, so Julia package manager. Package manager. Well, I'll just put the code in and see if it works. Here we go. So we're going to create, I guess I'll just call it main.jl. There was a good article on Hacker News from Donald Knuth about Babylonian algorithms. And yeah, sure, I'll get the data. The way the Babylonian algorithms work is they use a specific example, no abstract explanation. Okay, in case the packages are not yet added to your using package. But where does this go? Let's just try running it in here and see what happens. Okay. Yes, here we go. Just run it once and it will install the packages. Very good. Reading the data is done in a few easy steps. Specify the URL of the CSV file. Okay. Easy. Which is which? Let's start with this 22 meg file first. That's easiest, I think. I don't want to blow the machine up by loading in a 644 meg CSV. Yes. Okay, data frame. Pipe it into a data frame. Dun dun dun. Okay, so use CSV file, give it the path, pipe it into the data frame. Okay. And then print it out. Okay. Why only starting this Julia language server? Terminal. Okay, still downloading. General. Okay, I guess it's updating the package registry first, since I've never done that before. Good. Good, good, good. Hypotheses about data. Comparison of data from other years. I mean, in order to be able to actually make sense of the data, I'd have to correlate it with other data. But anyway, I need to be able to do something with the data first. Yeah, this is going to be interesting. Very good. And it says that it's going to emit this, but like, where is it going to emit it? Okay, so we can select, okay, data frames modified in place. 320 columns, epic. I think I downloaded the data for a state and I downloaded the data for the country. So 22 I think is for Rio de Janeiro, the 22 meg one. And the 644 megabyte one is data for the whole of Brazil. One thing that I think is missing from this data set, well, I don't know because I have to look at it. But yeah, I mean, it's not on here as like a breakdown by demographic segments. Cases and deaths. Let's leave it in Portuguese. Ministry of Health. Beloved country. Brazil. Federal government. New cases for day of notification with media mobile moving average over 14 days. Notified new cases with moving average over 14 days. Cool. I mean, not cool the cases or anything, but the actual amount of data that they have is like pretty cool. Graphs. I wonder what they generate this with. I wonder if they use Julia. Oh, really? It really takes this long to install these packages. Oh, come on. 99.9%, and then what, the other 0.1% takes like 99% of the time? Okay. I'm going to have to run this one again, package add CSV. Let's have a look. Updating the registry. Okay, updating the general registry. Fetching. 98.9, 99.9. Okay, it's pulled it down now. It's probably doing something with it. How long does it take to update the Julia registry? Question. How long does it take to update the Julia registry? Package registry. Registry. Pre-compile everything after package update and friends. Okay. Well, that's good to know. Apparently, it says here that this package get is the equivalent of apt-get on Debian-based Linux. And it says it's already slow as it is. I normally package update in the morning. I know it will take some time, so I typically do it when I don't need a Julia prompt the next second. Every time I try to demo Julia, it spends a couple of minutes pre-compiling things. Okay. This was 18 May 2016, so it sounds like it now pre-compiles. Closed. Pre-compile. Okay, let's go to the end and say, what did they do? There's now a precompile statement in the new package. Okay. Precompile. So this last 0.1% must be the pre-compilation, I guess. Load the files in a clone repo. Yeah, okay, whatever. Package manager for the Julia programming language. Project environment. Okay, I guess I could put this at the beginning of my program. Maybe. Let's have a look at what's in this actual... Okay. Right. That first package was called CSV. CSV. Nope, there's no package in there called that. Okay, whatever. Maybe it's in standard lib or something. General S for standard lib. No, not SAM tools. STD? No. This standard? Nope. Okay. It's just, goodness, it's not exactly thrilling viewing, is it? It's not exactly heaps of fun for me either. The getting started experience for Julia, I guess it's so specialized that they're kind of like, who cares, you know? Like, if you don't have enough intrinsic motivation to utilize this thing, to get past this, you don't need it. It's not for you. This is not like the kind of Ubuntu philosophy of like, we make Linux easy for you. This is kind of more like pre-Ubuntu Linux, where it's like, this is for the elite. You know, it's like, I don't mind waiting so long for this thing to download because like I'm part of an elite group of people who use Julia. And then maybe it's also so powerful once you get it going that you're just like hooked on it. But mass market appeal is not like a feature, I would say, for this particular environment. What happens if I click on this? Let's have a look at the CSV file. Yeah, it's cool. Don't do folding or anything like that because that'd be crazy. Latitude, longitude, Sigla UF. Latitude, IGB, postcode. District, latitude, longitude. So latitude, longitude. And then Sigla. Oh, okay, cool. I can mouse over it. That's good. Coordinatoria Regional. I don't know how you pronounce that. I think R is pronounced like a J, like H. Inconsistent number of fields. Header 39, this line. Oh, goodness. Okay. Region 16. What's this? Some macro regional health code. Macro region health. 13. COVID regional code. COVID region. Julia's doing something. Good. Let's see if this next one is going to be faster. Cool. Okay, that's good. Installed Xorg, FFmpeg. Interesting. HTTP. Okay. How's it going to do the output? Free type. Okay. libpng. Oh, okay. This looks pretty epic. It looks like basic Qt. Okay, what's it going to do? I tell it what the data is that I want and it builds an application or something? Like, interesting. Okay, maybe like that package download gives you like so much functionality that you just like, that was nothing. I could have spent hours coding this thing, but all I had to do was wait for minutes for it to all download. And I have to run the CSV one again. I mean, they just say, do this thing here and you get this. I'm like, where does it output this? Is this a web app? Does it make a PNG? Does it like display it in the terminal? Like, but it's like installing x264, libpng, Qt, Wayland protocols. I mean, I don't have Wayland on this machine. It's a Mac. FFmpeg, JPEG Turbo. Okay, it looks like it produces all kinds of graphical and video output. Epic. Epic, epic, epic. XSLT, libtiff, FFI, Cairo, XML2. Building. Yeah, and I just saw the other day that Ubuntu has landed on Flutter as their desktop application development framework. So that means Dart is going to get a real boost. I've always wanted to create a Dart node, a Dart library for gRPC for ZB, Command to Cloud. I maintain the node library right now, but Dart has always interested me. CSV's installed. Okay, so, I mean, it should be possible now to run this thing. What happens if I say Julia main.jl? Is that all I need to do? This is the Millennium Falcon moment where the guy wants to demo how amazing Julia is and how fast it is. And pre-compilation, is it loading the file in? Is it doing anything? Did I run the right command? Frequently asked questions, scripting. How do I run a script? Scripting, I got to there from here. So it's like getting started if you want to run a script. I remember it was there. Okay, see scripting. Here we go. Put this code into a script and then run it. Script. Okay. Okay, double minus color equals yes. So I might have to do this. Wah. Okay. Okay, that was kind of epic. It was obviously doing something, but let's run it with these these options here. Invalid option. Anyway, we'll just say minus color. So I'm going to make this into a README. Okay, so this here is a good article. And I'll put it on dev.to, I think. Getting started with Julia. I wanted to analyze some COVID data from Brazil. I got a 22 megabyte and a, 644 megabyte CSV file. From the Brazilian Ministry of Health. So I should provide links to where I got them from. It's good for me to remember where I got them from too. Open data source kind of means their public health system. This is where I got the 644 meg CSV file from. And the other one I got from here. Actually, I'm not sure which one came from where. No, actually, this is how I got to that other page. That's some other guy's project for doing it. I'm pretty sure I got to that other page from here. Let's close that. Where'd I get the other one from? I think Gustavo sent it to me. Reforming the Brazilian pension system. That's not it. Twitter. Let's have a look. Pretty sure it was from Gustavo. Notifications. All right, come on. Dun, dun, dun. Gustavo. Here we go. From here. This, I think, is specific to a particular region, or... Yeah, this is for the region. And I downloaded it from here by, yeah, export CSV. So I'm pretty sure this is the 22 meg data set. Okay. Dun, dun, dun. I used Julia 1.5. And then I can put a link to the Julia 1.5 installation. Okay, following this getting started guide article. Now this getting started article is nope. Here? No? Here. Towards datascience.com. Put the link and then grab the name. Okay. A couple of notes that aren't mentioned in the article. The package update. Is slow. At least the first time you run it. It will clone a Git repo. It will clone the registry. And go to 99.9%. Pretty fast. As long as you have a fast network connection. My network connection is pretty fast. But it stays at 99%. 99.9% for 99% of the time. Well, it is doing something. Maybe it has to pre-compile packages, or I don't know. The next thing is, okay, I don't know if this is the Julia that's actually doing this, because that's just not working for me. Let's do this. Oh, maybe it's the loading. Yeah, it looks like it's the loading of the data set. I guess that's something I could also Google. So let's just drop these things in here. Using CSV, using data frames, it wasn't that statement. Maybe it was that statement. This is good because I can see interactively where it is in the program. Okay, nope, using dates. Using plots. pre-compiling plots. Okay, yeah, it's pre-compiling. Running the application, a Julia application for the first time. It has to pre-compile any of the all of the packages, or any packages that you use. So the first run just looks like it hung. I debugged what was happening by interactively entering my script and saw this. Ding. Okay. Image. I'll put it in there. IMG. Precompile. Image is worth 1,000 words, eh? .png. Okay. Listening to tribal techno and Afro house mix from March 2020. Human Music is the channel. Okay, what's happening? Still pre-compiling? Man, this thing better have like all the bells and whistles. Like it just better literally analyze the data for me and like output all of the everything that I want it to. Because the amount of time it takes to get this thing to run is like, man. I thought I've become like, oh, npm takes too long. I use pnpm with Node because it reuses packages from a local kind of cached registry, sharing them, symlinking them into the project. But that's nothing compared to this. Even installing the ZB Node package takes some time because it has to run Node.jip and like build the C binary dependencies. Let's have a look at pnpm clean cache. What happens if I delete? What happens if I delete a project that uses packages in pnpm, but I don't remove them before I do that? Yeah, look at that. See, it's much faster. Instead of being like 40 seconds, it takes like 15. Frequently asked questions. Hard links. Yeah, hard links point to the same disk. Yeah, okay. Nested modules, approach incompatible, circular symlinks. Why have hard links? Why not symlink directly to the global store? I don't know. Multiple stores. What is it? Store prune. Removes unreferenced packages. Okay. Copy. Might as well run that while this is going because, like, why not give the machine more to do, hey? Let's see what this does. Removed all cached metadata files. Is that what I meant to do? Don't know. Copy and pasting commands from the internet. Not harmful, no side effects. See, you think I would have read that before I ran it, but whatever. YOLO. A future, yeah, it'll download them again. Run it occasionally, not too frequently. Yeah, okay, cool. Performant npm. Yeah, I dig it. I've had to do this once with a project. Wow, pre-compiling plots. It's still doing it. I feel this guy's pain. I feel his pain. Let's find that GitHub again. GitHub.com/Julia. This one here. Sums it up. Guess I'll add this here. Epic. Okay, that's done. Julia is still going. Far out. How long has this been? How long have I been streaming for? 47 minutes. Just trying to get the thing installed. Boy, you got to be really committed to getting this thing to work to use this. Hopefully once it's like pre-compiled, its packages and everything, it's like so fast that it loads a 22 meg file within seconds and then renders it into like a graphic, and I don't know how it's going to display it, but otherwise, it was going to be a real letdown if it doesn't. Oh, okay. Oh, visualizing the data. Plot. Oh, wow. Okay. Oh. Save the figure to disk. Wow. Okay. Wow, okay, cool. It's kind of like Excel, scripting Excel. Oh man, this is so much better than using Excel. Amazing. Yeah, I'm going to use this for data analysis of stuff. Scripting data graphs and stuff. Epic. But this pre-compilation, I'm not going to say it's killing me because it's like not literally killing me, but man, it's like taking a long time. That's definitely a fact. CPU is going nuts up here. What is the cause of this? 950% going to the kernel task. Mac, high kernel task, CPU, and I'm using Mojave. Is it because Apple wants me to upgrade? Are they like, okay, let's like peg the CPU? Okay. I mean, I've looked at these before, but yeah, let's just keep looking. How to fix your high CPU. Yes. Simple solutions. Okay, reset the SMC. Reset the PRAM. Simplest solution. A dodgy sound card. CPU. CPU time. Right. Okay, it's done. Righty ho. So I think if we try running the script again, should run to completion. What was I thinking? I'm real optimistic. Let's see how long it takes to load the CSV file. It's loaded. That was fast. Let's create the data frame. Okay, creating the data frame obviously takes longer. .22 megabyte file. I wonder what file formats Julia can work with. Can I use it with, I don't know. Let's have a look, Julia input file formats. Okay, any delimited file. Yeah. Open Mendel. Reading data from a file. Open file, do F for I line and enumerate each line. Print, okay. Okay. Reading structured data, CSV. tabs. Higher order functions. Okay. Yeah, cool. Map, fold, reduce, filter, for each. Good. Okay, it's in. Boom. There we go. There are the first 10, but let's try that again. Yeah. Yeah, okay, cool. Okay, but what do I actually have in this? Okay. Let's have a look. Oof. Come back. What happened? That's not what I wanted to do. I just wanted the first line. I want the headers. Hang on. Are you telling me that? No. So go to the end of this line, grab from here, and go back to there. Okay. Here we go. So semicolon delimited. So let's just go like this. All the way to the end. Okay. And then just go like that. So, okay, it's actually the data is broken down by establishments. Leitos, UTI adulto, public, private. Number of something, clinical something, adult. Leitos. Number of respirators. So this looks like resources available. Number of suspected COVID, SARS, Imlito, UTI. Maybe UTI means urgente tratamiento intensivo. So like ICU, intensive care unit, unidad tratamiento intensivo. ICU, intensive care unit. Emleito, maybe it means in treatment. Patients. Number of ICU patients, adults. Emleito, in beds. I'm gonna have to Google this. And when I say Google it, I mean DuckDuckGo it. Ocupa un curso de agua en condiciones normal conditions. A bed. There, beds. Okay, number of ICU beds for adults, number of ICU adult clinics, number of children's ICU beds, number of respirators, number of suspected COVID-19, SARS in beds, ICU beds, adults. Number of confirmed COVID in ICU adults in ICU beds, children, Suspected, confirmed, suspected in the clinic. Okay, in the clinic. Okay. But this data is for a single day. What I actually need is I need multiple days to get like what does the trend line look like. Anyway, this is a good place to start. Segment this data. It's segmented on children and adults. It doesn't segment it on any deeper demographic splits than that. Like how old are these adults who are in there? Let's go back to the data source. Comes from here. Export, this is a CV. 42 hospitals are behind. 299 hospitals. Last update, 7th of March. Okay. State, macro region, COVID region, districts, cities, hospitals. Okay, so 27 February is like a... Does it have a date in here? Nope, it doesn't have dates. So this looks like a single point in time, this data. Okay, well, it's a good start. It's like an hour just to get me to this point. Obviously, once the data is in here, it's a lot more malleable than it is in this format here. I got my program running. Yeah, I'll do some more on this. I'm going to continue with this as a little project to learn Julia and find some data sets and drill into the data. But that's enough for today. I will be back. Stay safe.